So Friday we went over factoring quadratics with basic form, right? And we just did it on the warm-up, so I won't reiterate that. But I assumed Friday you're familiar with that. Is that true? You've seen that before, you know the general form of a quadratic, right? So Friday, A was 1, and we factored this, just like on the warm-up. Okay, today, A is not going to be equal to 1. Okay, it could be 2, 3, 4, 10 million, it doesn't matter. You can still factor those. They get immensely harder with 10 million as A, but there you go. There are a few ways to do it. I'm going to show you 3 different ways to factor these. Hopefully you can find a method that works for you. Okay. So the first thing that you want to pay attention to is that. Do you remember what that means?
No. GCF.
Greatest common factor is what it means, yes. Okay. This is the first thing you look for. Okay. If you can factor something out, it's going to make your life easier. So if I give you a function like this, okay. Again, A is not 1, so the question is, can I factor that out to make this easier? Yeah, I can factor 2 out, right? So dads just don't know what to say. And then you can factor this very easily, correct? Just like we've been seeing. So our zeros are -5 and -4. Again, best to write those in order. Okay, so if you see a common factor that you can take out, do it. First. The 2? No. Because there's no variable on it. It's just a constant. If there was a 2x here, 0 would be a 0. But there's no factor on it, no x variable, so it just kind of disappears, to be honest.
There was 2x.
Basically, you're setting this, if we're to formally write this out, you're setting g of x equals 0. If I divide by 2, it goes away, right? So I would divide by 2 on both sides. These would cancel and it would still be 0 equals. Okay, so that's why we don't have a 0 result from that. Okay. Good question.
You had 2x cubed plus 18x squared plus 40x, and you had to pull out 2x as the greatest common factor? Like,
yes, you could do that too.
Does that change the zeros?
It does, yeah. So it's kind of a piggyback on her question. If this is not quadratic, but it can be, if I have a function, you said 2x cubed plus 18x squared plus 40x, right? I can factor an x out and a 2, right? So I would get 2x Now, we know these zeros, but this right here creates a 0 of 0, right? That's what you're asking, yeah. So, yeah, if you have a variable on this constant out here, it does give you a new 0.
And will it just be 0 when there
Yep.
is the...
Yeah, because there's no plus anything or minus anything. Yeah. Okay, so good question. Again, Cubics, not necessary yet. We're gonna go over that at the end of the week next week, so we'll head there. Okay. The second way to do these is probably the most tedious. It's guess and check. Okay. So let's grab one.
Yes, and check.
Yeah. Try that.
And then the next morning. Yeah, that one.
These get a lot easier if this number is prime. Right? We're trying to factor this just by guessing and checking. 3 is prime.
Well, I think this is how I usually no.
So we know that 3x and x have to be our first terms. Right?
This is that thing I was talking about, Mr. Arthur.
This is not that thing you were talking about. That's next.
Oh, you figured you learned
I
it?
figured it out. It's really easy. It's different than what you told me, but it's easy.
I had a problem like it on homework.
Okay, so we know that's 3x and x, right? These are both positive, so we know that these are going to be both positive, right?
Yeah.
Okay, so that implies these are both pluses. Now all we have to do is factor this and put those terms here to see what works. So what are our possibilities? Okay, so 1 and 4. Okay, so we're going to check. We're going to check 3 times 4 is 12x plus 1x. That's 13x. Does it match? Nope.
What about 2x?
And you just, okay, and you could also do 4 and 1. Is that going to work? No, 4 and 1 is going to be 3 plus 4 is 7, right? So, and the only other option is 2 and 2. So 6x, 2x, 8x, right? So we've just factored this appropriately because that matches the middle. Okay, that's guessing and checking. Okay. I wouldn't recommend it all the time just because this is not always prime. It does throw a big ball of mud at you if it's not, because you have several different things to check. But this is one way to tackle those ones with prime numbers as A. What are the zeros? Okay, so we do have -2, right?
-2 and what times 3 equals negative?
Okay, yeah, so some of you can do this in your head, right? Fine. If you have trouble with that, again, set the terms equal to 0 and solve. So subtract 2, divide by 3, you got your term there, okay? So guess and check what you process. Any questions? Random guitar playing in the back. You would like to serenade us, so let's get in line. In fact, okay. I'm not going to sing you another song. I'm not going to screw up another song. Okay, are we good here?
No,
It wasn't bad, but it wasn't very good. It wasn't very good.
He didn't do
I was
he didn't do his thing
struggling.
before lunch.
Okay, this method is something I learned this morning officially. I got a rough, incorrect introduction to it Friday, but I think this is probably your best method. Just from a teacher perspective, okay? I'm going to show you one more after this. It might work for you, but this looks like the most simple method to me. So if we take something like 3x squared plus 13x minus 20, and we want to factor that. Okay. This is our A and our C, right? All right, so take the A value, and this should be a 10, sorry.
So how do you know?
Apparently I can't read. Multiply those together. So we are going to get x squared plus 13x minus 30. So we've just multiplied 3 over to the 10. So we've slipped it. Right, slip and slide. We're getting there. Okay. Can you factor that?
Yeah.
Okay, what do you get?
X minus
And plus 3. Oh, wait.
Okay, it's got to be a plus and a minus, right?
yeah.
Yeah.
Somebody said it.
15.
Yeah, 15's got to be the positive, minus 2 then, right? Okay, so we factored that. We're going to place A back in these two factors, okay?
Wait.
So we've put A in there, we're going to take it back out, that's what we're doing. Okay, so you got to put it in, now you got to take it back out. So we put it in both of these. With the x term. Because we know one of them has to be 3, right? Okay, so put it back in there. Now, can I factor it out of either of those? Yeah, right here, right?
See, that's what I think.
3 goes into both of them.
It goes into 15.
We're going to leave this the same, 3x minus 2, and we're going to take that out of here. So x plus 5. All right, so we just factored out 3. And that's your answer. Okay. I haven't tried this with a non-prime A value, but I'm assuming it'll still work.
So how do you know when to do this?
Okay, because you might be able to factor out of both of these, right? And then it'll fall out. So this is a good method to use when A is not equal to 1. Okay, it's called slip and slide.
You need to use big and show us how to do 4 terms.
We will get to 4-term factoring next week. Okay, we're just focused on quadratics right now. Okay, good?
Yeah, I understand.
Third method? Okay. All right, here's the fourth.
Third method.
So we've got the greatest common factor, guess and check, and now we've got slip and slide. How many of you like biology? You like biology? How many hates biology? So if I call something the Punnett Square, you're going to vomit in the trash can?
Yeah.
It depends on what type of Punnett Square. Is the easy one or not?
This is the math Punnett Square. I don't know what else to call it.
How many?
Punnett, it's an N.
What?
Math punted.
You guys are terrible. Quit making fun of me, man. Okay, so let's take the same one from before so we can kind of compare the two methods. It's very similar. Okay. Very similar. We're going to use A and C again. We're just going to use it in a different way. So A times C is negative 30, right?
Yeah.
And we're going to factor that.
Negative 30?
Uh-huh. So we're going to list all the factors of negative 30. This is where it can get tedious if that's a really big number. If it has a lot of factors, we're going to have quite a big list.
Yeah, 1 and 30, 2.
You'd have to have one
But-
negative.
Okay, so 1 and negative 30. Do I need to list negative 1 and 30?
No.
Yes.
You know.
Yes or no?
Yes. Yes.
Why do you think we need to?
Because it'll probably give you a different outcome because of the 1 and negative instead of 3.
Right, it will, but if you look at your signs, the bigger number is negative, right? So I only need to label the bigger number negative. The middle's negative, so all I need to worry about is the negative being bigger, right? Little strategy there. Okay. 2 and negative 15. 3 and negative 10. 5 and negative 6, right? Which of those adds up to negative 13?
2 and negative 18.
Yep, there's our... Okay, so these two right here are what we're going to use, 2 and negative 15. Okay. Now we get to make our square.
Oh, regular square.
Yeah, like literally. So we call, okay, we know all the numbers in here now. Okay, we know 3x squared. We know negative 10. Do you mean to color code these? Does that help? Negative 10?
Do you have to put them in the certain boxes?
Yeah. So these always, this term always goes here, that term always goes there. Okay. And then the other two are 2 and negative 15. So we have 2x and negative 15x. Okay. Now we just need to figure out all the factors. So negative 10 shares a 2 with this, right? And it shares a negative 5 with this. Okay, so we're just seeing what's shared, what the common factor is here. So we're looking for common factors. Okay, what do these two share?
3.
A 3x, right? And what do these share? Just an x. Guess what? You just factored. Okay.
So it'd be like
So,
3x plus...
3x plus 2 and
Oh, okay.
x minus 5. You just factored.
No way.
That's it. Okay. So like I said, some of you might find this easy, some of you might like slip and slide. I don't care what you use, to be honest with you. If you can do it, fantastic. Okay? Again, zeros we can figure out from that, right? Okay.
Wait, why do you... Oh.
I thought Mr. President made it very clear on Friday, we're not making calls me cautious to school. Funny.
Well,
He's trying to get his butt.
he's trying to be funny, is what he's trying to do. Okay, tomorrow, completing the square and the quadratic formula, do you want me to tag one of those on today, or are we good? We're good. It's kind of a heavy day with both those items. Do you want me to show you the quadratic formula real quick? Because completing the square is kind of a monster. Yeah, so the other way to find zeros,
All over 2x.
okay, who wants to sing for us?
My dad does. He memorized this thing by heart.
How about you sing for us?
I sang for you last week. Who wants to sing for us? Does anybody know the
Why
tune?
did you do it?
Opposite b plus or minus the value of b squared, the square root of b squared plus or minus 4ac all over 2x.
Okay, it goes to Pop Goes the Weasel. Have you ever heard it?
Opposite b plus
X.
or minus
Okay, that's
square
one way to
root
do it.
b squared plus minus 4ac all over 2a.
There you go. X equals negative b plus or minus square root b squared minus 4ac all over 2a. There you go. You need to practice, son. So, I'll just give you some advice that this has to be memorized for calculus.
That is wrong.
That's a good way to memorize it.
That can you teach us this with the guitar?
The what?
Can you teach us this with the guitar?
Because I have none.
If I knew how to play Pop Goes the Weasel, I could.
I was gonna laugh on like a hoot if you got this wrong.
Okay, so I'll just give you a nasty one.
Oh.
Today we don't like to go into school and everyone
Trying to kill us.
Okay, so if I give you a quadratic and it's really ugly and I don't say factor or graph, this could be your default because this solves every quadratic. This works every time. It's exact and it works every time. Okay. Part of the problem with factoring is that it doesn't always work. You cannot always factor. It's exact, but you can't always use it. Okay? So, A, B. You guys complain a lot.
Yes, sir.
It's like, never mind. Okay, the B term is 3, right? Plus or minus 3 squared minus 4 times A times C. All over 2A. It's the Canadian quadratic formula. It's all over 2A.
2a?
Okay,
All
that's
over 2a.
stupid.
2a. Nice beaver.
Here's where people usually mess up. Right there. What is the result of we have 9, right? If this is never a negative number, this result. Okay, because a squared negative is always positive. That's one mistake I see. The biggest one is right here. What is this answer?
It's 89.
Negative 80.
Negative.
Ah, see?
89.
That's 2 out of 3 people just gave me the wrong answer.
No, I was like, I figured it out, and I was like going from
You
like
have
where
to
I started.
know that there are 2 negatives here, right? So make sure that you have the right sign here, or you're going to screw everything up.
Yeah.
Oh, wait.
Okay.
And then we're done.
Okay, now, is there a square root of 89 that's really nice?
Now.
No.
No. So this is an exact perfect mathematical answer, or you can leave it right here. Okay. I'm content with this. The only time that I would advise you to simplify this is if you're in a like a business application. Is this a good number for business to look at?
Absolutely not.
You're going to want a decimal, right?
Yes.
Right. So if you're in context, you'll want to figure that out. But mathematically, this is perfectly okay.
Delicious.
You do know there are two answers here.
You set them for 0, right?
No, this is it. You're done.
No, you want the
You
plus and the minus.
Wow, good day for you.
Don't make me, Micah. So we have 3 plus root 89 over 10 and 3 minus root 89 over 10. Okay. Those are your two decimals for your zeros because it's a quadratic.
Or 3 is negative. So it'd be negative.
Now we're even on the negatives. Wait, that doesn't make sense.
Wait, what?
It can be odd on negatives too. What?
Oh, is it always negative?
So you have 3 plus or minus? That's two answers. Okay. Last point here. What if I take the quadratic formula? Okay, last thing, be patient. What if this number is a negative?
Put it with an I.
Yeah, so I have a square root of a negative, right? We have an imaginary number or complex number. What does that tell me about the zeros?
They're not real.
Are not real. Okay, what does that tell me about the graph?
It's not a graph. It's sideways.
No.
It's just imaginary.
It's still up or down?
The x-axis is like imaginary, right? Or the
It just doesn't cross it.
You're making it, yeah, there you go. There are no x-intercepts.
Oh,
So it could look like this, right? No x-intercepts, or it could look like this. It could be happy or sad. Okay. It just doesn't cross the x-axis. Okay? It's called, if you want a math term, this is called the discriminant.
I thought you added over.
We like the discriminant in math class.
That's
Yeah, I know.
There's a problem.
Yeah. Okay. I already wrote this down last week, but for those of you that weren't here,
Is it the same homework?
Oh, you're adding to it. Let's do Thursday, add more.
I'm not adding today. The only thing I'm adding tomorrow is the completing the square worksheet.
Wasn't it 37 through 45 off?
No,
God.
39 through 45.
Wait, is that 5 through 11 on?
Yes. Okay, it's not a lot of work.
I'm pretty sure I'm almost positive.
Okay, well, it's right now. So, good thing we rewrote it.
39 through 45 odd.
Yeah, it's supposed to be.
No, it's not.
That's what it was last year.
That's what you wrote last time.
I know what Why can't we leave it odd?
It's 39 through 45. So I've added to your homework like I promised. There you go.
Yay,
I am asking you to do the evens. If you don't want to, I cannot force that upon you, but it will affect your grade. How's that sound? Okay, you have 10 minutes to suggest you try some work.